thank you. I'm honored to be here. Let me begin with this photograph. This is a photograph taken from the Mir space station of sunrise. And you can see the sun just starting to peek out over the horizon. And when you see this blue layer over the horizon, that's the breathable atmosphere. And this photograph just captures it perfectly. And it gives us an understanding about how narrow and fragile our atmosphere really is. And yet, we pour 40 billion tons of carbon pollution into that narrow, fragile atmosphere every year. And the carbon pollution does three major things that are bad. The first thing is some of that carbon dioxide actually, in contact with the ocean, diffuses into the ocean. And when carbon dioxide and water meet, it releases carbonic acid and it acidifies the ocean. And so the oceans are becoming more acid, which is wreaking havoc with marine life. The second thing that carbon dioxide in the atmosphere does is it changes the way plants grow. Plants utilize carbon dioxide from the atmosphere in photosynthesis. And when the carbon dioxide levels are higher than what the plants have grown accustomed to over the last 10,000 or the last million years, it changes the way they grow in ways that are disadvantageous to us. We'll get into a little bit more of that later. But the third thing it does, and the most important thing for this discussion, is the fact that the carbon dioxide layer in the atmosphere causes a greenhouse effect. And that's described in this cartoon. So what happens is the sun's rays hit the Earth, and about 40% of the energy that the sun's rays come to the Earth reflects back into outer space. These red lines, it reflects back into outer space off reflective surfaces like snow and ice and other reflective surfaces. And about 60% of it stays to warm the Earth. But this blue line here represents the carbon dioxide layer. It's now excessive in our atmosphere. And what happens is some of the radiation that bounces off the reflective surfaces hits the carbon dioxide molecules in the air and then reflect back down toward Earth. And so this right here is what's putting everything out of kilter. All right, that's why the planet is warming beyond anything that we've seen in the last, more than 1 million years. And we know that all this excess carbon dioxide is there. 75% of it is there because we are burning fossil fuels, and 25% of this excess is there because of land use changes. It's all human activity, and all changeable and all preventable. So what does this warming mean for us in Philadelphia? So right now, it's extraordinarily unusual to have a 100-degree day in the summertime in Philadelphia. It may happen once a decade or so. But within the next couple of decades, what we're going to be seeing is about a dozen days a year where in July and August when the temperature is over 100 degrees. And if we continue on the path we're on, by the end of the century, there will be more days in July and August with temperatures well over 100 degrees than under 100 degrees in Philadelphia. And then we add to that the injustice of the way this heat is distributed. We know that if you live in the suburbs with grass and trees, it's not going to be as hot as if you're in the city in a congested area with more automobiles, more blacktop, fewer trees. So we get heat islands that make this profoundly more extreme. So this is what happens to us in Philadelphia. What happens in the rest of the world? Well, we know that within the next couple of decades, there will be large swaths of the Middle East and North Africa that will be uninhabitable in summertime. And there will be severe drought. There will undoubtedly be wars and conflict over access to the Jordan River waters, and huge numbers of migrants from intolerable places to live. That's within the next couple of decades.
I'm sorry, literally a human being won't be able to survive in those places if
Correct.
It's too hot?
Correct. In fact, we've already had, there was a day in some town in Iran in the summer of 2016 where the heat humidity index reached 169 degrees. And survival for more than 4 to 5 hours in that temperature outdoors is not likely. What we're also going to be seeing in the northern plains of China, now home to 400 million people, including the city of Beijing, they're expected by 2070, 2080 to have heat humidity waves in the summertime, also exceeding the limits of human survival for more than a few hours. I don't know what they're going to do. So climate change is more than just heat. Heat is the driver of climate change, but climate is much more complex. And the heat drives climate change through 3 primary mechanisms. One is it disrupts the water cycle. So what happens is when the oceans are warmer, more water evaporates from the oceans. When the air over the water is warmer, warm air can contain and hold more water than cold air. So when the rains come, they're much more extreme. There's much more water to fall. But the converse is also true. When we have drought, because it's warmer, more water evaporates from the land, more water evaporates from the plants, and so droughts become much more severe. The other thing that happens is the jet stream is weakened. And one of the things that I didn't mention when I was talking about the greenhouse effect, and there's when the planet gets warmer, as it is, ice and snow melt. And when ice and snow melt, there's less reflective surfaces to reflect radiant energy back into outer space. So what's happening in the poles, we've lost half of our ice and snow in the Arctic. And so now when the sun's rays hit the Arctic, there's more land and water to absorb the heat and less snow and ice to reflect it back. So it's a feedback mechanism. The more warming we beget. But what's also happening is that the Arctic is warming much faster than the equator for that reason. And so the jet stream, which are those winds that power, go from west to east, and they power our weather patterns. So we know that if it's snowing in Chester County, a couple of hours later it's going to snow in Philadelphia, a few hours later in New Jersey, a few hours later up in Long Island. It's the jet stream that moves these weather patterns. And the jet stream is powered by the gradient in temperature between the equator and the Arctic. With that gradient being diminished because the Arctic is warming faster, what's happening is the jet stream is becoming less reliable, wavier, and less predictable, which is why weather patterns tend to stall, which is why Hurricane Harvey sat over Houston for 5 days instead of moving out to sea, because the jet stream wasn't powerful enough. That's why we're getting Arctic temperatures and Arctic vortexes with Arctic temperatures going as far south as the Carolinas, which we had last winter, while we had 70-degree temperatures in Alaska. So what we're seeing is weather patterns lasting longer and weather patterns occurring in a very unusual locations. And then ocean circulation is also impaired for the same reason. It's powered in part by the gradient in temperature. So the major trends, climate trends in the United States is on this graph. I don't know if you can see it well enough, but in the West, we're seeing drought and wildfires. Central states, we're seeing extremes of temperature. In the Southeast, we're seeing storm surges, hurricanes, sea level rise. And what we're getting in the Midwest and in the Northeast, we're seeing excessive rains and flooding. And so we're already seeing that. In Philadelphia, we've already had a 360% increase in heavy rains in a couple of decades at the turn of the century. And and that's only going to become more extreme. What we should expect to see in the Philadelphia area is actually more precipitation in the winter, more rain and snow, fewer episodes, but more intense episodes, but then drought in the summer and fall. So we're getting the worst of both. And that's a lot of moldy basements and a lot of stagnant water for fleas and flies to grow. So what's happening, there's the latest IPCC report came out and said that we're going to be losing 1 million species to extinction by the end of the century. And so what's happening is that we're losing habitat. We're losing habitat because of land changes, but we're also losing habitat because the plants and animals that have been evolved over 10,000, 20,000 years to coexist in a certain kind of ecosystem are finding these ecosystems changing at a rate much too rapid for evolutionary compensation. So what we're seeing is, for example, cues for migration, cues for mating are being disrupted. We're seeing certain species that might depend upon a certain air quality or a certain water quality, a certain salinity to the water, are seeing that their environment is changing in a way that they can't adapt. And then different species that unrelated that depend upon each other, for example, bees that pollinate plants, those relationships are being disrupted. We're also seeing individual and whole populations lost because of extreme events, wildfires and storms. So all these things are resulting in what the Pontifical Academy of Sciences has made the statement, and this is a quote: "Climate change is putting the very fabric of life on Earth in grave danger." And that's a direct quote, and it's because of these things. But it isn't just the toads that are at risk. It's our neighbors and our children. And so climate change is altering the air we breathe, the food we eat, the water we drink, and the weather we experience. And these changes affect our impact through direct effects such as changing air quality, air pollution, and heat stress. But it's also changing our health impacts through natural systems, through various infectious diseases and changes in the food quality that we're eating. And all of these things have socioeconomic effects that increase impoverishment, which then accentuate all the other problems. So I'm just going to go over a few of these highlights. I won't do too many because I don't want it to get too depressing, but this, I don't know if you can read this. This is a news press release from May 24, 2018, but there are many others. It's a press release from the Department of Environmental Protection. It was an air quality action day for all 5 counties of the Philadelphia area. And on Air Quality Action Day, young children, elderly, and those with respiratory problems such as asthma, emphysema, bronchitis are especially vulnerable to the effects of air pollution and should limit outdoor activities. There have been many of these same air quality warning alerts, and you can see them on your phone app if you have the weather channel after the radar. If you scroll down, you can see air quality indicators. So, according to the World Health Organization, air quality, the toxic air that we're breathing, is causing more mortality and more morbidity than tobacco on a worldwide basis. And you look out the window and it looks clear, air smells good, you smell the flowers, and it just doesn't kind of ring true that we're in danger just from going outside and breathing the air. But we are. The evidence shows very clearly that the air quality in all 5 counties of southeastern Pennsylvania was rated F by the American Lung Association for 2018. And this poor air quality is increasing the risk of coronary artery disease, emphysema, asthma, and it's doing it because of particulate matter from the burning of fossil fuels and automobile emissions, but also with the rising temperatures from climate change, the ozone levels are rising, but also pollen levels are rising. And pollen levels are rising because of climate change and because of the O2 and the CO2 in the atmosphere. We know that ragweed, for example, grows differently with the higher CO2 levels, and it actually produces more of the antigens. And the growing season is longer because of climate change. So we're expecting to see a tripling of the pollen levels in Pennsylvania over the next couple of decades because of climate change and because of the continued burning of fossil fuels. There was one study that showed that if we were to reduce, or if we were to increase our efficiency for energy use by 15%, it would reduce the number of asthmatic attacks in this country by 30,000 per year, with a 15% increase in efficiency. So let's go on to just heat. So if we define an excessive heat event day as a day in which the mortality is measurably increased solely because of heat exposure, that in the latter part of the 20th century, there were 6 of those days a year in Philadelphia. In the next decade, we're expecting to see 46, and by the end of the century, 73 days per year in which the temperature in Philadelphia alone by itself results in a statistical increase in mortality. And it's mostly the diabetics, the elderly, the impoverished who don't have access to air conditioners, people with heart disease and lung disease are the ones, and the extremes of age are the ones that are at risk.
Excuse me, why is the increase slower in Pittsburgh?
Well, I assume it's because we're going to probably be seeing more heat and humidity in Philadelphia.
Because of the ocean.
Yeah. So the mosquito season is growing. So the mosquito season is growing because the longer periods of warming, but also we're seeing more mosquitoes because of stagnant water after the heavy rains. Most people who are bit by mosquitoes are bit by a mosquito that was bred on or near their property. So make sure that after rain, if you go out, if you have any upside down pots in your property, any place where water might collect, you spill it out and don't allow standing water on your property. And that can help with your own personal protection. According to the CDC, diseases spread by ticks, fleas, and mosquitoes tripled in the last 10 years in the United States, and that's attributed to climate change. Pennsylvania is the epicenter of a Lyme disease epidemic, but there's a worldwide tick epidemic, and again attributed to climate change, and some people are calling the Lyme disease epidemic the first epidemic of climate change. But if you look at this map, the black dots in 2001 represent incidences of Lyme disease, and you see the change between 2001 and 2014. Every Pennsylvania county now has Lyme disease. If we had 2018 or 2019 on here, this whole area would be black. And the people most at risk for Lyme disease are people who hang out in tall grasses. So kids, children, golfers who don't know where they're hitting the ball, hunters, hikers, and Lyme disease can be prevented by spraying your clothes. Your children should all have their sneakers and their pants sprayed with permethrin. That's perfectly safe, doesn't stain the clothes, and it kills ticks on contact. So what happens with these excessive rains is that sewer systems overflow. And when they overflow, water sources, wells, irrigation systems become contaminated. They become contaminated with the overflow from the septic systems, but they also get contaminated with water runoff and toxins from things that we treat, fertilizers and other things get runoff. And so we're seeing an increase of all of these waterborne diseases. Now, more than 2/3 of waterborne disease outbreaks in the United States have been preceded by extreme precipitation events. But it isn't just that. Every once in a while we hear about these lettuce contaminations, the lettuce recalls from because of E. coli and salmonella contamination. A lot of that is due to the same thing. It's due to excessive rains in California, wherever these things grew, with water runoff, contamination of irrigation, contamination of the crops. So these are climate-related outbreaks that we're seeing. So this is a slide that was on the EPA website in 2014. Right? You can read it yourselves. This slide was removed from the EPA website in 2017. So let's move on a little bit to food supply. Again, food supply is very complicated. All of these factors are impacted by climate change, and they all impact our food sources. And so food scarcity is going to become a major problem. I mentioned a few times about plants growing differently in a high CO2 environment. By and large, most plants grow more rapidly when the CO2 in the air is higher. But as they grow more rapidly, they incorporate fewer proteins and fewer minerals, and so they become less nutritious. The other thing that happens is that many plants have their immune system is altered by rising CO2 levels, and so that many plants become less resistant to disease. So there are a variety of ways that our food supply is being negatively impaired by climate change. So this slide is slightly off topic. I put it in because my friend Dirk Gerstad, who used to work in this building, I don't know, maybe some of you might know him, but he was the coordinator for Central American and South American affairs for the American Food Service Committee for many years. So in Honduras and El Salvador, there was a severe drought, 2014 through 2016. 25% of Honduran workers were working in agriculture. There were widespread failures of the coffee crop due to the drought and disease. And according to international agencies, 1.3 million Hondurans that became impoverished because of this drought and needed humanitarian assistance. There was mass migration into the cities from the countryside in 2015, 2016, and into 2017 because of this drought. Social order broke down in the cities because they didn't have the infrastructure to absorb all of these new migrants into their cities. The migrants in our southern border, which so frightened some of our fellow citizens, they claim that they're trying to get into the United States mostly because of violence in their hometowns and their cities. The reason they had their violence is because they didn't have the social infrastructure to support the migration from the farms into the cities. What we're seeing in our southern border is climate migration. So, in summary, the public health gains of the 20th century will be reversed in the 21st due to extreme weather events, increase in waterborne, zoonotic, and waterborne infections, and better access to clean water overshadowed by water scarcity and worsening access to nutritious food. According to the U.S. State Department in 2014, climate change will likely lead to food and water shortages, pandemic disease, and disputes over refugees and resources. So, you all knew we have a problem, that's why you're here. So, the idea, I mean, can we fix this? Well, yeah, it's not too late to fix it. There are certainly things we can do, but we all have to take a part, every one of us, and we have to start today. And there are two aspects to dealing with this crisis. One is mitigation and the other is prevention. Mitigation is very important for us over the next few decades to limit the damages and the suffering that we and our neighbors will face. But ultimately, mitigation alone will fail because ultimately the catastrophe that our planet will face is beyond anything humans will be able to deal with. So prevention is important. And yeah, we can still prevent. It's not too late. And most of this conference is going to be about mitigation, and I'm going to talk a little bit about prevention. And so we have the means, we have the technology. If you look at what the predictions were for solar energy, most of the experts 10 years ago, when you asked what their prediction is, how much solar energy we would have in the world as of 2019, they were off by, we have 100 times more today than what was expected by most experts 10 years ago, because the prices are falling so dramatically and the efficiency is increasing so dramatically. And it's the same with wind energy. Wind energy is much more prevalent than anybody expected would be because the prices have come down. And if you look at the actual cost of energy now in the United States, let me get this back. So by levelized cost of energy, I'm referring to the 30-year cost of building the plant, the power plant, or the solar farm, operating it, maintaining it, and getting the energy for 30 years. If you look at that cost over 30 years, already wind and solar are cheaper than natural gas and much cheaper than coal and much cheaper than nuclear. These are now the cheapest forms of energy, and solar is still in free fall in terms of cost, and efficiency is still, year by year, we're still seeing improvements. So this, over the next few years, is going to fall way, way down below anything else. It'll be clearly the cheapest, most efficient form of energy and most prevalent. So already it's cheapest. The only thing that's holding it back from a widespread conversion are public policies which favor natural gas at the detriment of solar and wind. And it's those public policies that are inhibiting us, not any economic reason. And if you look in other parts of the world, in Germany, they had, on 2 days in 2018, they must have been windy, sunny days, but they had 100% of their electricity. Yeah, 5 minutes? Okay, almost done. They had 100% of their electricity generated by wind and solar, but they've had about 35% average over the course of the year. I just put this in to emphasize all the new technologies that are available. A lot of those are in the drawdown program. So we have lots of things we can do that would solve the problem. And anybody that tells you that somehow switching over to green energy would impoverish our children is either misinformed or outright lying. And if you look in California, they've already separated out GDP from emissions. They've proven that since 2000, the GDP, except for, here we had the recession, the GDP in California has increased dramatically. The emissions per GDP has dropped dramatically. There's been a dissociation proven in California between fossil fuels and growth. So anybody who says, we're inhibiting growth by switching over, they're just wrong. So let me just move on. I need to finish up here, and I'm just going to move on to, so we all need to be part of the solution. There are things that we can do in our own personal lives. I've listed some of these things here, and the important thing that I want to note is that if you're doing a little thing, one little person out of 1 billion, out of 7 billion, it makes a difference. because what you do is contagious. Your friends see what you do. And it's been shown that, for solar roofs, it's very hard to sell the first solar roof in a neighborhood. Not quite so hard to sell the second solar roof. But once 2 or 3 people in a neighborhood have solar roofs, the whole neighborhood shifts over. And if you go into a restaurant and and if people know, if you let the customers know that restaurant is selling less beef because people are concerned about the environment, people who are given that information order less beef and more vegetarian dinners. People are, these things are contagious. But you can also amplify your voice by joining groups. Someone mentioned Project Drawdown, that's a great one. But any of these groups, doesn't matter, they all work toward it, and you can empower yourselves by working with others. I think my time's up. Any questions or?
On some of the science programs or news that comes on, I saw something the other day, projections for out in the future of alternative things. For example, they had these things that look like they're not fake trees that take through the wind blowing through them, they take the carbon dioxide out.
Okay.
And, or facilities that take the carbon dioxide out of the earth. How realistic are those things?
That's a attempt at misdirection. A lot of the fossil fuel companies are doing research in industrial technologies to remove carbon dioxide. And I think the main reason they're doing that is because they want to lessen people's anxiety to think that we can fix this at some point in the future. We have something that removes not a fake tree, but a real tree. And there are farming techniques, and there are ways. For example, we have corn fuel, all right, and we subsidize corn to make fuel, biofuels. And that corn is an annual; it grows half the year. There are perennial plants that can be used for biofuels. They grow all year round, extract more carbon dioxide all year round, rather than just 6 months of the year or a few months of the year that corn grows. Why are we giving subsidies for corn biofuels when those same farmers, if they were given subsidies for perennial biofuels, would help extract it? So, we don't need, there is no industrial solution for extracting carbon. There's better land management for extracting carbon. We have a green roof in this building, and that's what we need. And that's been shown to work.
But once we have a price on carbon or a cap or a tax on carbon, technologies will be developed to try to capture carbon as well. But right now it's not a profitable thing, and so it's a little slower than it might be otherwise.